Hello and welcome to another engineering video. And this video is going to be all about circuit simulation, specifically circuit simulation using Tinkercad. Simulation is a thing that I make all of my students do. And part of my teaching philosophy is I try not to make my students do anything that's not actually useful to them. And simulation, whether it's electrical or mechanical, simulation is one of the most important things an engineer can do. Regardless of what we're talking about, it is always cheaper to find out that a given design won't work in a digital realm than it is once we have physical parts sitting on the shop floor or sitting on our desk, right? Um, the goal is to, in circuits anyway, not to blow anything up. So here, in like I said, it's a thing that I require all my students to do. So I thought I'd do a quick run through, just in case you're not familiar with Tinkercad simulation and some of the things. Tinkercad is free. It's an Autodesk product nowadays. Um, and it's good for a pretty advanced level of simulation, I'd say. I will do future videos on sort of the more professional level of simulation that's used when we get into more advanced topics. Um, in that realm, we're going to get into spice and things like that, but we'll save that for a later video. For now, I'm here. I'm at Tinkercad. This is my this is my dashboard. I've got some stuff I've worked on before. They allow for some 3D designs, which is a good way to get started 3D printing as well. There's also obviously a circuits and some code. So to get started here, I'm going to come up to my Tinker menu and I'm going to go to circuits and I'm going to start tinkering. Okay, never mind. I'm going to click create in circuits. Um, Now up in the upper left, it gives me a name. I'm going to change the name, demo analysis, just for me, but I can change that name just by clicking on it. You can leave it random. It doesn't really matter. Um, but it helps to keep things sort of the same. So for my purposes, most of the analysis that I'm going to do is going to start with a breadboard because that's how I'm going to prototype the circuits in a laboratory setting anyway. So over here in my tool pane on the right, I've got a breadboard small already. So I can just click that and I'm not dragging. I just clicked it to select it and I can drag it in. Now, if you're not familiar with how a breadboard works, Tinkercad does a pretty good job of sort of explaining it via highlighting. So if I just move my mouse over this hole in the breadboard, see how all of the top row there lines up green. That means internally, all of those are connected all the way down the length of the board. So anywhere I plug a wire in, it'll be connected to any other one. The red row is connected all the way down the red row. So all of these are connected together internally. The numbered rows here, or letters rather, rows, they're connected vertically. So these five holes are connected together, F through J. A through E are connected together, and there's a break in the middle. So when, for instance, I go to drop a resistor in, I can click resistor, and I want to make sure I cross two holes, right? I can cross, and these two, even though they're in the same column here, are separated by this sort of center line. So important to remember that quick little intro on how the breadboard operates. So the five holes are linked together, split by the center. So there's two groups of five that are linked, and then the horizontal rows here are all linked together. So we can put, say, power here on one side or common on the other side and link everything together. So we've started with a breadboard. This first circuit I'm going to do is going to be fairly simple. It's just a resistor circuit, and I've got a diagram here in front of me that I can sort of work from, but I'm just going to click a resistor. I'm going to drop it in place. And with it selected, I'm going to flip it because I want it to resemble the diagram that I have here on my paper. So this resistor I'm going to draw here, and I'm going to double click it. Let's click off and select. There we go. Click off and select. So name. This is my R. Whoops. Name. This is my R1 in my drawing. It has a 5 ohms, so I can change to ohms here from kiloohms. It has a 5 ohm value. Notice also important in the sort of circuit builder here in the middle, it also changed the color bands accordingly to give the right color code for a 5 ohm resistor. That's important to remember that it does that, so we can actually now walk over to the sort of the parts bins and grab the right colors for these resistors. So I'm going to just Control C, Control V, copy and paste another one in. This one I'm going to name R2. The resistance of my R2, according to my diagram, is 12 ohms. Notice again, the colors changed. Control V, paste another one in. This one I want to rotate because this one I want to span across the middle. This will be my sort of return loop on my circuit diagram. So I'm going to rotate it so it's vertical, drag it back, select just that resistor, drag it back over so it's in this column, but spanning the middle. So remember, there's no electrical connection across here. That one is R3 and it's 7 ohms. R3, 7 ohms. Enter. All right, colors again changed. I can paste another one in. Remember, these columns need to be in the same columns to have an electrical connection. So I'm there. This is my R4 and 6 ohms, and that's it for my circuit. R4 and 6 ohms. Okay, so there we have our resistor set up. Now I need a voltage supply. Over here on my right in sort of the basic components, you can see I've got a 9-volt battery. I could use that. The circuit I've got in front of me has 10, but I mean, using this battery is just the same as using any other component like a resistor or breadboard. Just click on it and drag it in. And then we have connection points, positive and negative. I don't want to do that because I like more variability if I need it. Plus my diagram here is set at 10 volts, not 9. So I'm going to search for supply. And in other components here, I have a power supply. So if I click that and drag it over this way, I am also, well, if I select it, first of all, we have our name. We can give it a voltage. In this case, it needs to be set to 10 volts. And this is just a DC power supply. If we needed AC, we would have to pick a function generator, which gives us all the various AC controls, right? So we don't need AC for this particular circuit. We just need a DC power supply. Now, connecting this guy to the rest of our circuit, I typically recommend setting it up so that you're using these outer sort of 2 rows or 4 rows for the power. And then sort of dropping power into these columns as necessary. So to do that, up here we have our wires. I'm going to select a black wire for the negative side of this power supply. I'm going to just click when it lights up red. I'm not dragging, I just clicked, and I'm going to drop it in that first hole. Those are now connected. If I move this, right, that black lead is now connected. Now I'm going to switch colors to red to keep my color code sort of straight here. I'm going to select the positive, just click, no dragging. I just clicked once and I'm good, and drop it on that hole. So now I've got my power supply set up and it's connected. Now I need to get power to the actual resistors. So to do that, I'm going to, again, remember that these are connected, but they're not connected to these outer rows. So I need to drop a wire from here to here in order to get power there. And I'm going to switch back to black, and same on the other side. I need to go from here to the black in this case to get my negative side of the circuit, right? So now I've got power connected, and I can actually come up here and hit start simulation, and it's running. And right here, it's showing what this circuit should be drawing. Now, while I have the diagram in front of me, I forgot to do the math for it ahead of this video, and I really don't feel like pausing and editing a video later, but I would bet if we ran Ohm's law on this series resistor circuit, we would come up with 333 milliamps of total current draw. So right here is already going to give us the total current draw for this circuit. So that's one of our simulation results. That's one of the results my students would be looking for and I would be looking for, right? What's the overall draw? Now, usually I'm going to ask students for voltage drops across resistors at various points. And knowing I'm going to do that, I'm actually going to move this resistor down. So anytime, first I have to stop the simulation up here in the upper right. And anytime I can drag these around and move them. So I'm going to move them just to consolidate a bit to give me a little, I can see it coming that I'm going to get a little tight for, whoops. See, I clicked a hole on accident. We don't want to do that. I'm going to get a little tight for space with what I would like to do. So I'm just shifting things around, and that just takes a little playing with it. And things can always be moved and relocated. I can always click the end of this wire. I could add jumpers in that same hole. I don't recommend in Tinkercad specifically, I do not recommend, even though I can click this red and drop, say, another wire. I do not recommend doing that because you can't do that in a real breadboard. We can't double up on holes. So I recommend setting this up exactly the way your physical breadboard will be set up. Keeps things nice and clean that way. So as far as voltages across resistors, this is a thing that I would normally ask my students to do. So I'm going to come over here, and instead of supply, I'm going to look for meter. And I hit my DPS button. I hate when that happens. And that's really slow. There we are. We're back to something normal. We'll click on multimeter, and there's a multimeter right here. So I can drop this in, right? It's a multimeter. It's right now set for voltage, so I'm going to leave it that way. I can now draw wires from here to here and change to red. Remember, I want to keep my, whoops, I need to deselect before I change to red. And here, and remember, since everything's linked, no, remember the green indicates what's all linked together. So I'm really getting a voltage reading across this first resistor, the 5,000 or the 5 ohm resistor. So if I start my simulation, I get a result here with a voltage drop of 1.67. So now I'm going to have to stop in order to change this circuit. I can add another multimeter. I can either move these leads to the next resistor, or I can show all of my resistors on one picture, one image, just by adding more multimeters. So I'm going to drop a positive here, deselect before going to black this time, drop a negative to the other side of this second resistor. And now if I start my simulation, I've got two different voltage drops, right? And I can continue to do that, drop another multimeter in. Um, Positioning is kind of important, but if black would go here, and this is one of the things I was worried about. Black will go here. I don't like wires crossing. That's just me being picky. Um, one thing we can also do, I need to be in this row here. One thing you can also do if things get sort of ugly, like say this, right? We can also rotate the meter to sort of keep our leads straight. Um, and that can sometimes help out just to make things a little pretty, because remember, ultimately this would be destined for some sort of report, right? Um, we want to keep this looking somewhat neat, even though we wouldn't put, all 5 multimeters or 4 multimeters around here all at once. It's not a terrible idea to actually do it just for the sake of keeping things clean for now. So let's see, I still got red selected, so I'm going to go ahead and red to here, deselect, and go black to here. And again, if it bothers me, I can always rotate this fully upside down now, is to sort of make it clear where those wires are coming from and where they're going. So if I start my simulation, I now have voltage drop at across every resistor, along with the overall current draw. I can do the same thing. So this would be, first of all, this would be sort of one example I would use for if I were doing a lab report. And what I would do is I would probably just screenshot this. That's the easiest thing to do, is just, actually send to. I don't think I've ever actually done picture of your design. There we go. So we can download just a picture, and there we go. So this works. I was going to take a screenshot, but this right here is what I would drop right into the lab report, and then I would talk about the results, maybe even throw them into a table, right, in the simulation section. So I can do the same thing, the same idea anyway for current. The problem with current is that, remember that amp meters need to be in line. So I'm going to go ahead and start deleting things. Delete all these meters. Let's, for instance, let's pull this over here. Um, yeah, that works, I think. We'll pull that over there and drop a new multimeter in. This one, I'm gonna change this to amperage, and we'll draw our negative. Remember, we're connected vertically. We don't want to go off the end of the resistor because there's no electrical connection between here and here. We want to go vertically, deselect, switch back to red, and drop it in here. Now I'm not connected anymore because I'm so far apart. I need to go from this column to throw a reconnection in there. And in the case of a physical breadboard in like a laboratory setting, these are literal physical wires. These would be jumper wires, right? That we sort of plug in. And if I start my simulation, notice 333 milliamps, 333 milliamps total. That makes sense because this is a series circuit. The current everywhere should be the same. So that at least makes sense. So that is, in sort of the very basic sense, how we create a circuit simulation using Tinkercad. If we were to do something more advanced, like say AC, I already showed how to get an AC function generator in, but the meter is limited in that it will not read AC outputs. And I had trouble both with current and voltage. Getting it to read it. It just the simulated the multimeter tool or multimeter object or whichever they call it is only for DC. So if we get more complicated and get into AC circuits, we actually, instead of a multimeter, there is an oscilloscope tool. So there's an oscilloscope object. So we can set the times per division. It only reads the voltage. So one big limit to pay attention to using Tinkercad is that it cannot read AC current at all. This meter won't do it, and neither will this oscilloscope. But the oscilloscope will give us AC voltage, which is good enough in a lot of cases. So we just need to sort of tweak our time per division, and it will automatically adjust the voltage scale on the vertical grid. So it functions just like a standard oscilloscope that way. It'll automatically adjust our height. So that is a primer on using Tinkercad um, for circuit simulation. So hopefully that was helpful. Again, simulation, whether it's electrical or mechanical, I cannot stress enough how important a good simulation is, because again, it is a whole lot cheaper to make our mistakes here in Tinkercad than it is once we have an actual circuit blowing up on our desk. So thank you for watching, and I look forward to seeing you back here for another engineering video.